for understanding the actual concept of kinetic energy in different motion such as translation, rotation, and combination of both. Let us discuss the kinetic energy in translating motion for rigid body. In translation motion, every line segment on the body remains parallel to its direction, and all points moves along straight lines. Then the motion is rectilinear translation. If the paths are curved, then we can say that motion is curvilinear translation. We know that a rigid body consisting of a large number of small particles, every particle having mass delta m, the motion of translation means all particles move with the same velocity. Therefore, kinetic energy of translation for a single particle is equal to 1/2 m into v square, where m is mass of particle, and v is velocity of particle. While considering kinetic energy for whole body taking summation of masses of all particles. Now, kinetic energy of whole body is 1/2 summation delta m into v square. Now, turn towards the rotation motion. Consider a rigid body rotating at an angular velocity omega about a fixed axis, intersecting the plane of motion at O. When body is rotating about fixed axis, then body has both translational and rotational kinetic energy. For a particle p having mass m, the velocity is equal to radius r into angular velocity omega. First, we consider kinetic energy of rotation of particle p. Now, total kinetic energy of rotation. Here, the term 1/2 summation delta m r square we can called as mass moment of inertia of body about axis of rotation. Now, the kinetic energy becomes half of I into omega square. Therefore, total kinetic energy of a body is kinetic energy of translation plus kinetic energy of rotation. In general plane motion, we consider kinetic energy in both translation and rotation motion. A piston changes linear motion to rotary motion. Also, we will see the example of bicycle. By studying this topic, we analyzed the rigid body in different motion. Also, we understand the kinetics of rigid body.